High-speed bus communication is essential to the operation of the modern vehicle. Possible faults on a high-speed CAN can include a short to ground, short to voltage, short between the two wires, or an open circuit. It's not difficult to diagnose these faults if you follow the correct procedure. In this module, we'll be concentrating on bus wires shorted together. This is the schematic for the vehicle we'll be using. As you can see, there are 9 modules on the high-speed bus, all connected by twisted pair wiring and going to pins 6 and 14 on the DLC. Before attempting to do any diagnosis, we should always check the battery voltage. Modules will not be able to communicate without the correct voltage. If you suspect a high-speed bus fault, it's important to determine which, if any, of the modules are communicating. Using a scan tool is the best way. Depending upon your scan tool, there are many ways to do this. I've found there's no communication with any of the modules. It's now necessary to do a resistance check between pins 6 and 14 on the DLC. Remember, the bus must be asleep to get the correct measurement. I'll check to see if the bus is asleep by measuring the voltage between pins 6 and 14 on the DLC. The bus is asleep, so I can now take my resistance measurement. And as you can see, I have a very low resistance. That would indicate that the 2 bus wires are shorted together. A short between the bus wires can occur in any module or anywhere along the twisted pair wiring that connects to the DLC. It's now simply an elimination process. Referring to the schematic, I'm looking for a place to split the bus in half. Connector CA230 would be the best spot. Once this is disconnected, the DLC resistance check is repeated. If the low resistance is still there, then it must be on the DLC side of the connector. If it's 120 ohms, it will be on the other side. Let's check on the vehicle. I've unplugged connector CA230 and the resistance is still low. This has eliminated 4 of the modules on the bus. Referring back to the schematic, I'll follow the bus to the next connector, which in this case is the climate control module. Unplug the module and recheck the resistance. If the resistance is still low, then the fault will be between the DLC, CA230 and the climate control module. If the circuit is now open, then the fault must be in the module or the remainder of the circuit. To check the module, I measure the resistance between terminals 9 and 10 or 22 and 23 of connector IP101. If a low resistance is not found, then reconnect the module. I'll disconnect the J-gate module and repeat the DLC resistance check. If the reading is now open circuit, the fault must be in the J-gate module or the remainder of the circuit. If the low resistance is still there, then it will be necessary to disconnect the yaw rate sensor to determine if it's in the wiring or the module. I've disconnected the J-gate module and the low resistance is gone. Checking the resistance of the module terminals 9 and 10 or 11 and 12 on IP14 will determine if it's the module or the remainder of the circuit. The module's okay, so I'll reconnect it and go back to the schematic. It is now necessary to disconnect the steering angle sensor. If the low resistance is now gone, then the fault is in the sensor. If not, it must be in the wiring or the instrument cluster. With the steering angle sensor disconnected, the low resistance is still there, so the sensor is not the problem. The last module on the bus is the instrument cluster. Disconnecting this will determine if it's in the module or the wiring between the J-gate module, the yaw rate sensor and the instrument cluster. With the instrument cluster disconnected, The meter shows that the low resistance is gone. The fault must be in the instrument cluster. That's the process for finding a short in CAN high-speed wiring. It's not a difficult process, but it does require a logical sequence of elimination until you find the fault. Don't forget to look at our other 2 modules on CAN high-speed diagnosis. And always remember, training is the key to your success. Bye for now.